Morning, everybody. Welcome to your class. Starting up in about 7 minutes for those who are wanting to fast forward. Start up in 7 minutes. Good morning, everybody. We are getting started in just 2 minutes from now. Twill be amazing. And as I have hinted to in the comments, very, very exciting news coming up for you at the end of today's lesson. How good is that? Oh, I think they just said a bad word. All right, we're up to 17 people. It is 11 o'clock. It is time. We're going to get started. So welcome, everybody. Welcome. As noted, we are getting started with our lesson today, and we have some very, very exciting news about what is coming up. I've got much more direction as to how we will end off this beautiful year. Your final year in high school for many of you. Your final semester, and what has boiled down now to your last 4 weeks of school. We went through this stat before. If you think of kindergarten to the end of grade 12, you are in school 2,500 days, approximately 2,500 days. You will wake up in the morning and head off to school. Out of 2,500 days, you've got 20 left. You are at 2,480, 20 days left. Let's finish the year off strong. Let's spend our 6 hours a day in chemistry and your 5 minutes a day in math and get through this the best we can. Today, it is brand new stuff, but it is the last thing we're going to do this year. I'm going to touch on it today. We're going to have a few applications of it over the next few weeks, and then I'm going to show you indeed how this year will end. We have much more clear direction. Some of you have already been on the snapogram back and forth, rumors flying and abounding that things are. That's why 21 of you are already watching instead of the 5 or 6 that we get sometimes. Here we go as to what integration is, and very fittingly, we'll then talk about how to integrate you back into the classroom. What? Did he just say that? Yeah, I'm going to go through that and we'll see what's happening. Now, first things we're going to do with integration is we're going to talk about what derivatives are again. So if you remember, what if I asked you to take the derivative of x squared? You know you would bring the 2 down to the front and bam, you'd have 2x. But what if I asked you, what's the derivative of x squared plus 4? Well, you'd bring the 2x down to the front. The derivative of 4 just disappears. So it's also 2x. Things that make you go, that's one of them. What if I asked you to take the derivative with respect to x of x squared minus 9? The 2 would come down to the front and the 9 would disappear. So the derivative of x squared is 2x, the derivative of x squared plus 4 is 2x, and the derivative of x squared minus 9 is 2x. Unbelievable. The derivative of all 3 of those things is 2x. But now I want you to imagine we're going backwards. There's many different functions that could have a derivative of 2x. I could make that x squared plus pi, x squared minus e. Everything will have a derivative of 2x. So what if I asked you to go in reverse? What if I asked you, what function did I have if I ended up with a derivative of 2x? Well, I could have had x squared. I could have had x squared plus 4. I could have had x squared minus 9. I could have had x squared really plus or minus any constant. And that's why we write it as this. That fancy thing that looks like the letter S, a fancy S, that's an integrand. The integral sign, it means to take the integral or to undo a derivative. So look again at the three examples on the left. It says the derivative of x squared is 2x. So that means the integral of 2x must be x squared. That's all that fancy sign means. It means undo the derivative. Go back to where you started from. Look at the second example. The derivative of x squared plus 4 is 2x. So maybe the integral then of 2x, maybe that's x squared plus 4. Look at the third example. X squared minus 9. Take the derivative of x squared minus 9, you get 2x. So what about an integral of 2x? Well, that could be x squared minus 9, or x squared plus 4, or x squared plus anything. The c just stands for a constant. So whenever we are doing integrals, when we undo an integral, when we undo a derivative to find the integral, we just slap a plus c on the end. These are known as indefinite integrals. There's no set space we're looking at. I will be going over that with you at a further date. Exciting news coming up at the end of this lesson. So let's go through the steps. If I asked you, take the integral of 2x dx, and if we hadn't done all those examples, I just slapped it there and said, hey, x squared, no problem. Let's see what we do. What did we do with derivatives when we started using Emma's rule for the first time? What we did with the derivatives, we brought the exponent down to multiply it, and then we subtracted 1. So think of those two steps. The exponent comes down to multiply, and then we subtract 1. Well, what would undo that? The last thing we did was subtracted 1. So now the first thing we'll do to undo that is to add 1. When we brought that exponent down, we multiplied it. Now to undo it, we'll divide. So let's look at this. Take the integral of 2x. What is your exponent right now? Look, there it is. There it is. Your exponent is right there. Currently, that exponent is 1. So how do you undo that? We are going to add 1 and then divide. Always, that's how you take an integral. Add 1 to the exponent, that makes the exponent 2, and now divide by 2. You had 2x. Now add 1 to the exponent to make it x squared, and then divide by that exponent, and you'll see the 2's will cancel. You'll end up with just the x squared. And don't forget, add c at the end. It's some sort of magical constant. Let's try some for yourself. I'll give you just a second. You can, if you're writing things down, you can do that on a piece of paper. If you are just visualizing it, well, you got that. 3x squared dx. Find your exponent. What is it? It's 2. What do you do to that exponent? Add 1. Then divide. You got this. 3x squared, to take the integral of that, add 1 to the exponent, then divide. That would give you, making the exponent 3, but then divide by 3. Bam, there it is. No more integral sign, we've dropped that. It's 3x cubed over 3, and then plus that magic c. But notice what happens. The 3's will cancel at the front. and we'll have just x cubed. Let's check your work. Take the derivative of x cubed. And sure enough, when you take the derivative of x cubed using Emma's rule, 3 will come down to the front. You take 1 away, 3x squared. Perfect. The derivative of x cubed is 3x squared. So the integral of 3x squared is x cubed. Now you try this next one. The integral of 7x cubed dx. Look at your exponent, add 1 to the exponent, divide by that new exponent, and you got it, Pontiac. Right now your exponent is 3. Add 1, that'll make it 4. Then you divide by 4, and you got your answer. There it is, plus the magic C that I've tried to make as big and bold as possible. Just to remind you, you add a C at the end with these indefinite integrals. Let's jump ahead a little bit and make it way more fun. What? That is way more fun. We're now going to take the integral of 5 over x cubed minus 1 over 2x squared plus 5x minus 9. The dx at the end that you've been seeing it just means with respect to x. Just like with derivative notation, we would say dy dx just means we're taking the derivative with respect to x. Dy dt just meant that we're taking the derivative with respect to t. The dx at the end just means we're taking an integral with respect to x. So the first thing we can do, we haven't actually taken the integral yet. I'm still making it an integral. However, I've taken the x to the 3. I've thrown it to the top as an x to the minus 3. Sorry about that crazy minus sign. Didn't work out with the fonting the way I wanted it to. That really fonted that up. The 1/2 is still good. The x to the 2, I made x to the negative 2. And then plus 5x minus 9 dx. So now, think of it. I'll give you just a second to race ahead. Try each term individually. 5x to the negative 3. What do you change that negative 3 exponent to? Add 1. Don't make it negative 4. That's taking 1 away. If you add 1, you see that first term would be 5x to the, that's right, negative 2. Now you've changed the exponent to negative 2. Divide by negative 2. Bam! There's your first term. Minus 1/2 x. See how that's being raised to the negative 2. Add 1 to it. If you add 1 to that, you now have x to the negative 1. Now you divide by negative 1. And see how it was minus 1/2 in the front? That now becomes a positive 1/2. Amazing. Then we have plus 5x. That exponent is a 1. Add 1 to make it a 2, then divide by 2. You got minus 9. That's x to the 0. Add 1. Now it's x to the 1. And then you divide by 1. We should have got this. Okay, 5x to the negative 3. Add 1 to make it negative 2, but then divide by negative 2. X to the negative 2. Add 1 to make it negative 1, but then we divide by negative 1. That changes the minus 1/2 coefficient to a positive 1/2. 5x. Add 1 to make it 2, then divide by 2. And finally, minus 9. That's x to the 0. Add 1 to make it x to the 1, and then divide by 1, and then don't forget your c. Now, if you don't like those negative exponents, the answer I have on the right side is exactly the same answer as the one on the left side. I just took the x to the negative 2, threw it on the bottom as a x squared. Oh, that should be, the minus 5 is now at the top. Then the x to the negative 1, I just throw that x to the bottom, and you're at 1 over 2x. 5x squared over 2 minus 9x, and our magic c. And that's it. That is today's lesson. I'm going to go through, as I've been hinting and teasing, some very, very exciting things for your homework. I'm going to send you an assignment with a link to a website. That's all I'm going to do. I'm going to send you an email. You click on the link. The answers are shown on the webpage. Like when you get to that website, you'll see there's a question, and then right next to it, there's a thing that says solution, and it can show you a detailed solution or just the raw answer. Do as many of them as you'd like. You should be able to do the first 5, but then start going through. If things are multiplied together, you'd multiply them out before taking the integral. If it's a fraction with an x on the bottom, you would divide everything by x first. Do as many of them as you like, but you really should be able to tackle the first 5, even if all you do is just look at the answers for that. That's amazing. No set time as to when you hand that in. None at all. You don't even have to do this if you don't want to. You don't have to report a mark to me. So Callum, you should enjoy that. What we have is some very, very exciting news. Next week is our last week of online learning. I've got 3 classes for you, Monday, Wednesday, and Friday. That will wrap up integrals as we know them. That will also take us to the end of May. Starting June 1st, you might have heard the rumors, school is back in. That's right, school's in for June. What I will be doing is I will be in my classroom from 11 until 2:30 every day. We are being told we are allowed 6 students at a time. So I will be setting up half-hour blocks, 11 to 11:30. 11:30 till noon, noon till 12:30. You get how that goes. I could keep going, but I think you get it. And so what we will be doing is we will be back in class, and you can sign up with me. I will have a thing on the board that I know you're coming in. When you get to school, and this will be the same for all classes, so if you do have the warden, she's probably already sent you an email saying 4-hour classes are back in vogue, and you'll be in her lab for 4 hours. We are not allowed to use computer labs, so you'll need to bring your own computer if you're going to do computer work. We're not allowed to use science labs, so you'll be studying virtual labs for 6 hours a day. So here's what you can do. If you want to come in and want to talk about your grade, if you want to come in and bring me your textbook back, if you'd like some help with calculus, whatever it is you would like, we are back in business. You'll be allowed to be in there for half an hour so you can get anything you need. There will be only 6 desks set up, and if you are one of the first 6 to sign up, you can come in, we can talk. It will be fantastic. You can come in once in the final 3 weeks if you want and say, I'm good, I'm done. I will be giving you assignments online. No more handing them in though. This will be enrichment for you. After next week, I am pretty much done with you as far as saying, Callum, get your homework to me. Callum, where's your assignment? Or just using a random name. I don't want to mention anyone in particular, so I'll just make up a name. Wallum Keeb, get your assignment into me. So we could do that. But you're basically on your own for the month of June. If you want more calculus, you can come in every day. If I don't have 6 people signed up, I can let you stay all 4 hours if you want, and we can do all the enriching we want to do. Anyway, all good. That is our exciting news. I'm sure if you have another teacher, they will be contacting you and letting you know, hey, you're coming in at 11 o'clock because you're only at 94 and we need to get your markup. Anyways, enough of that. That is the exciting news. We have a class Monday at 11. I'm going to email you the link to that other site right now. Mark asks the question, so those in-class days won't be lessons, just extra help. Yes, that is exactly true. There is to be no new teaching. What we were told, we had a staff meeting this morning, from 8 in the morning until 11, that's the time new material is delivered to you online. So from 8 until 11, you can expect a fun chem lab or chemistry of some sort for those 3 hours. Then you're permitted to come into the school for 3.5 hours. So you could do that. Colleen asks how we're going to sign up. I'm going to be emailing everyone a form that sort of says, look, these are my hours. And then just I'll let you know when I'll be emailing that to you. And then it'll be sort of a first come, first serve basis. And Ellery will, now that nail salons are back open, if you have a protective mask, you can do that. I'm getting a haircut on Tuesday for the first time in 3 months. I don't know if you see that show, Ancient Aliens, but Giorgio, the crazy guy that says, here we have writing on the sidewalk in chalk in front of the school. There's only one way that could have been done. Aliens. That's me. That's my hair right now. So I'll fix that up so I don't scare you. But yes, that's the sort of idea, is that any new material will be delivered online. What we'll do for this class, because I can't speak to other wardens and how they're going to be running their classes, but for this particular class, I will be sending you articles or links and saying, hey, if you want to, look this up. And then if you want more personal help with that, you are welcome to sign up, come on into school, and we can talk about it at the blackboard or whiteboard. You'll sit in your desk. I will sit far away from you and talk. And it will be neat that way. All right. So yes, Ellery, for your nails, if you want to schedule around that, you will need a mask. They will be wearing their plexiglass shields and all will be good. So that's an introduction to integrals. It's also a way for you to sort of wrap up the year and get a perspective as to what you'll be doing. We will be all done by June 19th. That is the last day. We have to have our marks in by June 22nd. So that applies to all your classes as well. There's next week. That's the last week in May. Then we go to this revised schedule for June. They may give it more structure that says block A, this will come in this time or whatever else like that. It is not mandatory. You do not have to come into school. So if any of you are thinking, I'm not sure it's safe, I don't want to be in the building, that's fine. None of your teachers are allowed to make it mandatory that you be at the school. Okay, so if any teacher is making it mandatory for you, let your parents know. They will let the school know, and that will be sorted. It is all voluntary. It is all good. So I look forward to seeing you Monday in class. We're going to sort of expand on these integrals and then start to talk about the purpose of them and what they do, some applications in real life. It will be amazing. Long, I understand you physically can't. You are the epitome of social distancing right now. You're doing very good. So you don't have to come in, obviously. Nothing else will happen like that. So it's not mandatory. In that time, it would be nice if each of you could make a quick appointment, even if it's a 10-minute appointment to come in. You can sit far away from me at a desk or stand there in a fragrance-free, virus-free atmosphere. You can wear a mask if you'd like and tell me how the semester went for you. You can throw your textbook on my desk and we can say goodbye from a distance. That would be fine as well. So anything that you need to do over the last 3 weeks in this class, my job for the next 3 weeks is going to be just to see you out of high school and make sure it's all smooth sailing. Speaking of a boat, I'll get you all out of here. It will be amazing. That's it. I'll send you the link right now. Do as many of them as you want over the weekend. You don't need to report any marks to me whatsoever or any Sawyers to me whatsoever. And I will see you Monday where we will have another class. If you do have any questions, feel free to send me an email. I'll be glad to answer them. Until Monday, then, thank you. And good night from NBC News.